Welcome to AEL. In today's video, we'll break down the IGBT in a beginner-friendly way. By the end, you know what it is, how it works, and where it's used. What is IGBT? IGBT means Insulated Gate Bipolar Transistor. An insulated gate bipolar transistor is a power semiconductor device that combines the features of two other transistor types: the high input impedance and voltage control of a metal oxide semiconductor field effect transistor and the high current carrying capability and low on-state voltage drop of a bipolar junction transistor. An IGBT has four-layer, PNPN structure, with alternating layers of P-type and N-type semiconductor material. P+ substrate, this is the collector layer, heavily doped with P-type impurities. N- drift region, this is lightly doped N-type layer is crucial for blocking voltage and affects the breakdown voltage of the device. P- body region, this region forms the base of the PNP transistor within the IGBT structure. N+ source region, this region is heavily doped with N-type impurities and forms the emitter of the IGBT. How IGBT works. When no voltage or a negative voltage is applied to the gate terminal of the IGBT, it is in its off state. In this condition, the device acts like an open circuit, blocking the flow of current between the collector and the emitter. When a positive voltage exceeds a certain threshold voltage between the gate and emitter terminals, an electric field is created. This electric field forms an inversion layer in the P-body region under the gate, similar to how a MOSFET operates. This channel allows electrons to flow from the N-emitter region into the N-drift region. The key difference from a pure MOSFET is what happens next. The N-drift region is lightly doped and would normally have high resistance. However, when electrons are injected into it, they attract holes from the P-collector region. This injection of minority carriers into the N-drift region significantly reduces its resistance. This phenomenon is known as conductivity modulation. With the resistance of the N-drift region dramatically reduced, a highly conductive path is established, allowing a large current to flow from the collector to the emitter. The higher the gate emitter voltage, above the threshold, the more pronounced the conductivity modulation, leading to a lower on-state voltage drop and higher current capability. To turn off the IGBT, the positive gate emitter voltage is removed or reduced below the threshold voltage, often to 0 volt or a negative voltage. This removes the electric field, and the inversion layer under the gate disappears, effectively closing the IGBT. Comparison with IGBT, MOSFET and BJT. MOSFET are fast and good for low voltage. BJT are best for high current and are used for slow switching. IGBT are best for both high power and current control application. Applications of IGBT: motor drives, EV inverters, UPS systems, induction heating. Advantages of IGBT: IGBT has high efficiency and has low losses. Limitations of IGBT: IGBT are slower than MOSFET at very high frequencies. If this video helped you understand IGBT, hit the like button, subscribe for more electronics tutorials, and let me know in the comments what topic you'd like to see next.